This problem we want to divide. It's the only directions we're given just to divide. First, there's a lot going on here. I have a lot of trinomials, so immediately I'm thinking about factoring. We also have to take a second and remember, what do we do in division scenario? So I'm going to write some side notes up over here. So if I had the problem like 2/3 divided by 4/5, let's say. In this scenario, when I'm dividing fractions, what I'm actually doing is I am taking the first fraction, changing division to multiplication, and then taking the reciprocal of the second fraction. So it becomes division becomes multiplication, 4/5 becomes 5/4. And then we start to perform some cancellations or multiplications, like whatever will be the next follow-up steps to that. So that's one thing we have to keep in mind, that we can't just factor each trinomial here. I'm going to factor this, I'm going to factor this, and then we try to cancel if possible. Can't do that just yet. We need to get this into multiplication. So I could take the route of rewriting it. So here's what I'm going to do. I'm going to flip this, change this to multiplication, but I'm also going to factor as I do this because I don't want to rewrite one line and then having to scroll down. I want to try to keep the first problem within eyesight here. I don't want to have to keep scrolling up and down. So I'm going to leave it like this, and then I'm going to factor as I rewrite this next line. So I'm going to factor x squared plus 3x plus 2. What I'm looking for here is I want two numbers that multiply to 2, add up to 3, because I want it to multiply to this term, add up to the middle term. So that's going to be 2 and 1. 2 times 1 is 2, 2 plus 1 is 3, okay. X plus 2, x plus 1. Nothing too crazy there, I don't think. Next, I want two numbers that multiply to 6, add up to 5. So that's going to be 3 and 2, right? 3 times 2 is 6, 3 plus 2 is 5. So x plus 3, x plus 2. And then this is going to be the multiplication, because remember what I said, when you're dividing fractions, you need to change it to multiplication and then take the reciprocal of the second fraction. So that's going to become multiplication. Now this x squared minus 4 term, this is going to come up, but I'm going to factor it as I'm doing this so I don't have to rewrite 3 different lines and add on an extra 2 minutes to this video. So I'm going to bring this up. So x squared minus 4 is a difference of 2 squares. So that's going to be x plus 2 and x minus 2. Just a difference of 2 squares formula there. Remember, this is coming up, and then this is coming down. So now, a little bit of a difficult factoring here. I need two numbers that are going to multiply to -2, add up to a -1. Negatives always give people some trouble. So two numbers that multiply to a -2, add up to a -1 is going to be -2 and +1. -2 times 1 is -2. -2 plus 1 is -1. Boom, got it. So that's going to be x minus 2, x plus 1. Okay. Now that I changed it to multiplication and I flipped it, now I can look to simplify it down and cancel it. One little quick note I do want to make though. In this scenario where we have these fractions, what notes we do want to make, now some textbooks I've noticed don't do this for when we're just multiplying or dividing two like polynomials together like this. Some textbooks won't make this side note. Some textbooks do. I've noticed this. I've seen a couple different college algebra books or intermediate algebra books like do this where they don't actually identify what x cannot equal. So what we can't have is we can't have x in the denominator, or I'm sorry, 0 in the denominator. That's what I'm trying to translate here. We can't have 0 in the denominator. So since I can't have 0 in the denominator, I want to think about what values would 0 out my denominator. So I'd have to make a little note here that x cannot equal -3 because -3 plus 3 is 0. X cannot equal -2 because -2 plus 2 is 0. And then I also have to look at my original problem, like before I change it to multiplication. So what would 0 out my denominator here? That would be +2 and -2, which I already accounted for -2. So x cannot equal +2 also, because +2 squared minus 4 would 0. -2 squared is +4 minus 4 would 0. And then I have to now keep in mind what these values would be that would zero out my denominator in my new problem that I changed from division to multiplication and flipped. So x cannot equal positive 2, which I already noted. Yeah, I already noted that, sorry. And then x cannot equal negative 1. The reason that some textbooks don't even address this right now in this problem is because we're not solving for x. Like, we're not actually, there's not an equal something, so we don't have to worry about solving for x. But it is good to know that, well, x can never equal any of these values right here, because that would zero out my denominator at some point. So we don't want x to equal that, but we're not actually solving for x or anything. So that's, I understand why some textbooks don't do it at this point in time, and some textbooks do. But besides the point, let's continue on. I debated whether I should even make a note of that. Okay, so now I have multiplication. So what we're looking for now is some simplifications that can be made, meaning do I have some common factors that can cancel out? On the top, I have x plus 2. Do I have an x plus 2 anywhere in my denominators? Yes, I do. I have it right below. So those are going to simplify down to 1. X plus 2 over x plus 2 is 1, so those cancel. X plus 1. Do I have an x plus 1 anywhere in my denominator? Yes, I do, right here. X plus 1, x plus 1. Next, I have another x plus 2. That cannot cancel out with this x plus 2 because these canceled out already. So that x plus 2 is going to stay. Then I have an x minus 2 with another x minus 2. So boom, bam. Whoop, pen slipped. Redraw that. And then nothing else. So when the dust settles and everything calms down, I am left with that x plus 2 on the top. And I am left with that x plus 3 on the bottom. So this would be my answer. Keep in mind of those values. And then I can cancel out these. I'm just joking. No, I always, if you've seen any of my videos before, I mention that almost constantly. That mistake that I see all the time is people doing that. I always see that when you're new to this concept, you think, oh, I see an x and an x, those are going to cancel out. Those do not cancel. This is x plus 2 and x plus 3. So those will not cancel. They are just x plus 2 and x plus 3. You always want to think about, what if x equals, just make up a number, like 5. This is technically 5 plus 2 and 5 plus 3. I wouldn't just, when I'm adding fractions, I wouldn't do that. Like, no one in the world would say, oh, those 5s are going to cancel because it's 5 plus 2 and those are going to cancel. It doesn't happen. So that's what you got to keep in mind, that this term here, x plus 2, is a way to represent like a single number. Whatever x is going to equal, this represents that number, that x equals, plus 2. That number, plus 3. So that's why I'm not going to cancel out those x's. Just want to make that little side note. Okay, so good problem there. And again, I don't know if this is what you want to see or not, like this whole x is not equal. Some books do it at this stage, some books don't. Kind of just depends. So hopefully this helps you out with dividing polynomials like this.